Right, so 1.2 goes over equations in two variables, graphing those, as well as circles. So we're going to start with just filling out the function table for a given function. You'll see here that it tells you to sketch and graph the equation 2x minus y is equal to 3. So what they did is they solved the equation for y, they put it in slope-intercept form, and then put it into a function table for us to find the values of our ordered pairs. So in order to turn this into y is equal to, or put it into slope-intercept form, we can move that y over by adding it to both sides. This would give us 2x is equal to y plus 3. And then we would just move the 3 over by subtracting it. So y is equal to 2x minus 3. That's how they're getting this equation in our function table that you see here. So with this, we are just given values of x. We're plugging them into our formula, and we're getting our y values, which give us the ordered pair x comma y. So with our first one, we have negative 1. We're just going to plug that in. 2 times negative 1 minus 3. Then we have 2 times 0 minus 3, 2 times 1 minus 3, 2 times 2 minus 3, 2 times 3 minus 3, and 2 times 4 minus 3. So the 2 times negative 1 minus 3 gives us negative 5. That's going to give us negative 1, negative 5. The 2 times 0 minus 3 is negative 3, so that's 0, negative 3. The 2 times 1 minus 3 gives us negative 1, so that's 1, negative 1. The 2 times 2 minus 3 gives us a positive 1, so that is 2, 1. And then the 2 times 3 minus 3 gives us 6 minus 3, which is 3. So that's 3, 3. And then 2 times 4 minus 3 is 5. So that's 4, 5. For these, if you were to graph them, you're just plotting the ordered pairs, and you would realize that it is a straight line, diagonal straight line, and your slope is 2. So it's up 2 to the right 1. We are going to skip that slide and go back to it. Right now, we're going to keep working on what we were just doing. So we're just given the function table with the function y is equal to x squared minus 2, and we're filling in the values. So they give us x values of negative 3, negative 2, negative 1, 0, 1, 2, and 3. We, like I said, just fill in these values. So we're going to do negative 3 squared minus 2, negative 2 squared minus 2, negative 1 squared minus 2, 0 squared minus 2, 1 squared minus 2, 2 squared minus 2, and 3 squared minus 2. When we simplify these, that negative 3 squared is 9, minus 2 is 7, so that's the ordered pair negative 3, 7. Then we have negative 2 squared, which is 4, minus 2, which is 2, so that's negative 2, 2. Next, we have negative 1 squared minus 2, which gives us negative 1, so that's negative 1, negative 1. Next, we have 0 squared minus 2, so that's 0, negative 2. Then we have the 1 squared minus 2, which gives us the ordered pair 1, negative 1. Then 2 squared minus 2 gives us 2, 2. And 3 squared minus 2 gives us 3, 7. So this one would actually be a parabola. It would be just like a u. Anytime you have that x squared, you have that u on your coordinate plane. For our next one, we have the x values of negative 3, negative 2, negative 1, 0, 1, 2, and 3. We have the function y is equal to the absolute value of x. So we are just plugging in the negative 3 in the absolute value bars, the negative 2, the negative 1, the 0, the absolute value of 1, the absolute value of 2, and the absolute value of 3. So these are going to give us the ordered pairs -3, 3, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, and 3, 3. So any absolute value function is literally a v. Next, we get into y-intercepts. So x and y-intercepts, an x-intercept is where that line crosses the x-axis. You want to set your y value to 0 and solve for x. Whenever you are giving your x-intercept, you are not giving what x is equal to, you're giving the ordered pair something comma 0. With your y-intercepts, it's where the line crosses the y-axis, so you set x equal to 0, and you solve for y. So those would be the ordered pairs 0 comma something. For our first example, we are finding the x and y-intercepts of the graph of the equation y is equal to x squared minus 2. So for this one, our x-intercept, we're going to solve for x when y is 0. So that's going to be 0 is equal to x squared minus 2. We add that 2 to both sides when we have x squared is equal to 2. We then take the square root of both sides to get x instead of x squared, and we put that plus or minus in front of that radical. So these are going to give you the equations negative square root 2 comma 0 as well as the square root 2 comma 0. So these are your x-intercepts. For your y-intercepts, we are going to find y when x is 0. So we're going to have y is equal to 0 squared minus 2. That 0 squared cancels out, so y is equal to negative 2 when 0 is x. So this gives us the ordered pair 0, negative 2 for our y-intercept. For these examples for 49, we are given the equation y is equal to x squared minus 5. So same thing for our x-intercepts. Plug in 0 for y, solve for x. So 0 is equal to x squared minus 5. We add that 5 to both sides. We get x squared is equal to 5, and we take the square root of each side, getting rid of the power, so it's just x is equal to, and putting that plus or minus in front of that square root of 5. When we write this as an ordered pair, we're going to have the negative square root 5 comma 0, as well as the positive square root 5 comma 0. For our y-intercept, we're going to plug in 0 for x, and we're going to solve for y. So y is equal to 0 squared minus 5. That 0 squared cancels out, so y is equal to negative 5. This gives us the ordered pair 0 comma negative 5 for our y-intercept. For 51, we have y minus 2xy plus 2x is equal to 1. So we're going to find our x-intercept first, which means we're going to plug in 0 for y. So it's going to be 0 minus 2x times 0 plus 2x is equal to 1. The 0 and the 2x times 0 cancel out, so it's just 2x is equal to 1. We divide each side by that 2. So we get that x is equal to 1/2. That's the ordered pair 1/2 comma 0. For our y-intercept, we're going to plug in 0 anywhere we see an x and solve for y. So y minus 2 times 0 times y plus 2 times 0 is equal to 1. The 2 times 0 times y cancels out, and the 2 times 0 cancels out, so it's just y is equal to 1, which gives us the ordered pair of 0, 1. For 53, they give us the function y is equal to the square root of x plus 1. So again, we're going to find our x-intercept by plugging in 0 for y, so that 0 is equal to the square root of x plus 1. To get rid of that radical, we're going to square both sides. That gets rid of the radical and the power, so 0 squared is 0 is equal to x plus 1. We move that 1 over, and x is equal to negative 1, so that's the ordered pair negative 1, 0. To find our y-intercept, we're going to plug in 0 for x and solve for y, so y is equal to the square root of 0 plus 1. This 0 plus 1 is 1, so y is equal to the square root of 1. The square root of 1 is positive 1 and negative 1. So that's plus or minus 1, which gives us the ordered pairs 0, negative 1, as well as 0, 1. For 55, we have 4x squared plus 25y squared is equal to 100. Now, this, because you have an x squared and a y squared in there, is not a function that you've probably seen before. If you were in pre-calc and came back down to college algebra, you've seen it, but if you were not, you probably have never seen this before, and it just means that you have a circle, okay? With this, if you're solving for your x-intercept, you're going to plug in the 0 for y, so you're going to get 4x squared plus 25 times 0 squared is equal to 100. The 25 times 0 squared you can cancel out. You don't have to work with it. So then you'd have the 4x squared is equal to 100. You divide each side by that 4 to get x squared is equal to 25. You then take the square root of both sides and get that x is equal to plus or minus 5. This gives us the y-intercepts of negative 5, 0 and 5, 0. To find your y-intercepts, you're going to plug in 0 for x, so that's going to be 4 times 0 squared plus 25y squared is equal to 100. From here, the 4 times 0 squared is just 0, so you can cancel that out, not work with it. You have 25y squared is equal to 100. You divide each side by that 25. So y squared is equal to 4. Take the square root of both sides, so y is equal to plus or minus 2. This is giving us the two ordered pairs of 0, negative 2, as well as 0, 2. So like I said, you have 4 different intercepts since this is a circle. For the equation of a circle, you need your center and your radius. Your center is the ordered pair h comma k. It goes into the formula x minus h squared plus y minus k squared is equal to r squared, where r is your radius. Your standard form of the equation of a circle with a center of 0, 0 is just the equation x squared plus y squared is equal to r squared. Now, what we did in the previous lesson when we found our midpoint and used our distance formula, we are going to use with this section as well. So if we look at the next set of examples, we are sketching, we're finding the center and the radius of the circle that's given to us in these equations. So for 67, we have x squared plus y squared is equal to 9. We don't have anything with the x, we don't have anything with the y, so our center is 0, 0, and our radius is the square root of that 9, which is 3. Same thing with 68. We have x squared plus y squared is equal to 5. So if we take the square root of that 5, that gives us our radius. So our center, since there's nothing with x or y, is 0, 0. And your radius is the square root of 5. For 69, you have x minus 3 squared plus y squared is equal to 16. So to find our radius, we're going to take the square root of that 16. Your radius is 4. To find your center, the 3 in the parentheses with the x minus is your x value. It's just 3. Y squared does not have another value with it, so your y is 0. So your center is 3, 0, and your radius is 4. For 70, your center for this one, because the x squared doesn't have another number with it, is 0. For x, y is at 2. Your radius is the square root of that 4, which is 2. For 71, we have x plus 3 squared plus y minus 4 squared is equal to 25. So our center is the opposite of that positive 3, so negative 3 for x, opposite of that negative 4 for our y, so positive 4 for y. Our radius is the square root of that 25, which is 5. For 72, we have x plus 1 squared plus y plus 2 squared is equal to 36. So opposite for our center of our x is the opposite of positive 1, so it's negative 1. For our y, opposite of positive 2 is negative 2. So our center is negative 1, negative 2. Our radius is the square root of that 36, which is 6. So center is negative 1, negative 2. Radius is 6. For 73, 74, and 75, we're finding the equation of the circle that satisfies the given conditions. So for 73, it gives us a center of negative 3, 2, and a radius of 5. So 73, the center is negative 3, 2, and the radius is 5. So with this one, we are going to plug this into our formula. So this would be our h, this would be our k. We're plugging it into x minus h squared plus y minus k squared is equal to r squared. So just plug these values in. So we're going to have x minus a negative 3 squared plus y minus 2 squared is equal to 5 squared. X minus a negative 3 turns into x plus 3 squared plus y minus 2 squared is equal to 5 squared, which is 25. For 74, we have a center of negative 1, negative 3, and a radius of 3. So again, we're going to plug this in. Our h is our negative 1, our k is our negative 3, our r is our 3. So plugging it into x minus h squared plus y minus k squared is equal to r squared. This is going to give us x minus a negative 1 squared plus y minus a negative 3 squared is equal to 3 squared. The double negatives turn into a positive, so this is going to be x plus 1 squared plus y plus 3 squared is equal to 9. For 75, I'm going to bring this up here and work up here. 75, we have a center of 0, 0, and it passes through the point 4, 7. So the first thing that we have to do is to find our radius. When we find our radius, we are using these values in order to find that radius. So with this, we are going to put this into our distance formula to solve for our radius. So we're going to have our radius is equal to the square root of the difference of our y values, so 4 minus 0 squared plus 7 minus 0 squared. This is going to give us the square root of 4 squared plus 7 squared. The 4 squared is 16. The 7 squared is 49. So our radius is the square root of 33. Again, if we have a center of 0, 0, and a radius of the square root of 33, we're just plugging it into our formula. Our h is 0, our k is 0, our radius is the square root of 33. So plugging it into our formula, x minus h squared plus y minus k squared is equal to r squared. This is going to be x minus 0 squared plus y minus 0 squared is equal to the square root of 33 squared. The x minus 0 is just x squared. The y minus 0 is just y squared. And the square root of 33 squared is 33. So we have x squared plus y squared is equal to 33. With our next part of this, for example A, for this example, we are finding an equation of a circle with a radius of 3 and a center of 2, negative 5. So A, we have a center of 2, negative 5, and a radius of 3. So with this, we're just going to plug it in. This is h, this is k, this is r. We're going to use x minus h squared plus y minus k squared is equal to r squared. So this is going to be x minus 2 squared plus y minus negative 5 squared is equal to 3 squared. So the x minus 2 squared is going to stay x minus 2 squared. The y minus negative 5 squared is y plus 5 squared. And the 3 squared is 9. So our equation is just x minus 2 squared plus y plus 5 squared is equal to 9. For B, we have to find the equation of a circle that has endpoints of P, which is 1, 8, and Q, which is 5, negative 6, as the endpoints of a diameter. So P is 1, 8. Q is 5, negative 6. So first thing that we have to do is find our midpoint between these two to find the center. So to find our center, we're going to use our midpoint formula. So we are going to add the x values, divide those by 2, then add the y values, divide those by 2. So we have 1 plus 5 divided by 2, and 8 plus negative 6 divided by 2. The 1 plus 5 is 6 over 2. The 8 plus negative 6 is 2 over 2. So our center for this one is 3, 1. Now use your center with one of those points to find your radius. So I'm going to use our center as well as point P, which is 1, 8, in our distance formula to find our radius. So we have the square root of 1 minus 3 squared plus 8 minus 1 squared. The 1 minus 3 gives us negative 2 squared, and the 8 minus 1 gives us 7 squared. So this is going to be the square root of 4 plus 49. 4 plus 49 gives us 53. So our radius is just the square root of 53. So we have a center of 3, 1 and a radius of the square root of 53. Plug these into your formula for a circle. We have x minus h squared plus y minus k squared is equal to r squared. Your h is your x, your y is your k. So we're just going to have x minus 3 squared plus y minus 1 squared is equal to the square root of 53 squared. The square root of that 53 squared is just 53. So this leaves us with x minus 3 squared plus y minus 1 squared is equal to 53. For your next and last example, it goes over types of symmetry. I don't think you have a problem in your practice assignment that has to do with this, but it is something that is good to know. If you have symmetry, you have respect to the x-axis, you have symmetry with respect to the y-axis, and then you have symmetry with respect to the origin. In order to test these, you use your negative or the opposite of all of this. So with your respect to the x-axis, you're going to just replace your y value with negative y and simplify. If you get the same exact thing that you started with, then you have respect to the x-axis. If you have respect to the y-axis, you're going to replace the x with the negative x, simplify. If your equation ends up as the original one, then you want to make sure that, or you say that there's symmetry with respect to the y-axis. And then if you have respect to the origin, you replace x with negative x and y with negative y at the same time, and the resulting equation is equivalent to your original one. So if we look at our last example here, we're given x is equal to y squared. So if we're going to check first to see about the x-axis, think about these as opposites. So if you're checking the x-axis, you're going to put a negative in with your y. So if we do x is equal to a negative y squared, then the negative y squared, negative y times negative y is a positive y. This is x is equal to y squared. This is the same as your original. So this is symmetry with respect to the x-axis.